Welcome to lesson 11-2. This is the Pythagorean theorem. By the end of this lesson, you should be able to use the Pythagorean theorem as well as identify right triangles. Remember, right triangles you're already familiar with? We're going to use the Pythagorean theorem and we're going to be able to identify, is a triangle right based on this theorem. For today's lesson, you're going to need graph paper is what we're beginning with, as well as some scissors to cut a little strip off the graph paper, and a pencil and a ruler. Go ahead, get those supplies out. When you're ready to go, hit play. Okay, so with our graph paper, we're going to start out by drawing a 3 by 4 triangle. Just in general, when we draw a triangle, we're going to call it A, side A, B, and C. We're going to be drawing right triangles. So side lengths A and B are in between the right side, and then C is opposite the right angle. Okay, we're going to make a grid too. It needs to have room for 3 lines going down. And you should label it A, B, C, A squared, B squared, and C squared as your columns. Alright, so for this first triangle we drew, which has a side length of 3 and 4, so our side length A is 3, side length B is 4. You know A squared, 3 squared is 9, B squared, 4 squared is 16. We're going to go ahead to figure out how long our C side is. You can't count the squares here, but you can go ahead and cut off a strip of your graph paper here on just the edge of your graph paper along the bottom of the graph paper. Cut off a piece. It's nice and long. We're going to use that to measure. So you're going to line that. You're going to line that up along the edge of your graph paper here. And you have the little grids going across, and you're going to count how many spaces is it. How many spaces are here in order to figure out how long the side C is. Go ahead, cut it out, measure. When you figured it out and filled it in your table, fill in C and C squared, then you can hit play on the video. Alright, you should have found that the C side was 5 units long, and C squared then is 25. 5 squared is 25. Okay, I'm going to have you draw another triangle that has side A of 5 and side B of 12. I'm going to go ahead and draw this triangle out. So 5 and 12. So 5 squared is 25. 12 squared is 144. You're going to use your little paper measuring strip and figure out how long is side C. Go ahead, pause the video, figure it out. Press play once you have found C and C squared. Okay, C should have been, when you measured it, there should have been 13 squares. So C is 13. 13 squared is 169. Okay, we're going to do one more drawing. It's going to have a side length of 9 and a side length of 12. So a squared should be 81, b squared should be 144. Go ahead and draw this triangle out. So you should have 9 and 12, and you're going to find side C, measure it, fill in C and C squared, hit play when you found them. Right, you should have found that side C is 15, and 15 squared is 225. Okay, so now we're going to make a hypothesis. We're going to kind of form a hypothesis about this information in this table here that you just filled out. So we're going to say a squared plus b squared, leave a blank, and then c squared is greater than, less than, or equal to. Based on the information in this table, what you filled out, look at the a squared, b squared, c squared side. Determine is a squared plus b squared greater than, less than, or equal to c squared. Go ahead, test all those different ones, see what you think, form a hypothesis, and then hit play once you're ready. Alright, you should have found that 9 plus 16 equals 25, 25 plus 144 equals 169, 81 plus 144 equals 225. So you should have been able to say a squared plus b squared equals c squared. You should have been able to say a squared plus b squared equals c squared. All of that, all of this chart, this information that you just proved, you just illustrated the Pythagorean theorem. So we're going to go ahead, done with our graph paper now. I'm going to draw us a triangle. I want you to go ahead and draw one on your paper. Draw a right triangle. We're going to label this triangle. So the two short sides are called legs. So we have a leg and a leg. And then the longest side here, the longest side is always called the hypotenuse, or the hypo. It's opposite the right angle, so you could draw a line opposite the right angle to the longest side. That's the hypotenuse. The legs, or the right angle, is sandwiched in between the two legs, and the hypotenuse is opposite. And the Pythagorean theorem shows how these how the legs are related. The legs and the hypotenuse are related to one another. We're going to take a note on the Pythagorean theorem. So the Pythagorean theorem is just that in any right triangle, the sum of the two squares of the lengths of the legs are equal to the length of the hypotenuse. So if we called this leg a squared, this leg b squared, or sorry, not b squared. If we called this leg a and this leg b, and the hypotenuse we called c, we would have a squared plus b squared equals c squared. That's the Pythagorean theorem. This is a theorem you're going to need to memorize. We're going to be using it a lot for future math classes. And in geometry, you're going to prove the Pythagorean theorem. But you got pretty close to proving it just now with that activity with the graph paper. You were able to show that when you drew these different triangles, this statement is true, that a squared, or this one leg here, the square of it plus the square of this other leg was equal to the square of the third side. So now we're going to use this theorem to find the length of the leg or to find the length of the hypotenuse. If we have three different numbers, if we have 2 out of the 3, we're going to be able to solve for the third unknown side. That's using the Pythagorean theorem. So we're going to do some examples together. So example 1 of using the Pythagorean theorem. If we have a triangle right triangle with sides 6 centimeters and 8 centimeters, and we have side C that we don't know the length of, we can use the Pythagorean theorem to find this third side. So we'll start by writing the Pythagorean theorem out. A squared plus B squared equals C squared. We can go ahead and say we know these are both legs because C is opposite our right angle, that's the hypotenuse. So we're going to solve the hypotenuse. So we can plug in what we know. We can plug in 6 squared plus plug in 8 equals C squared. So we're going to go ahead and just solve and find the unknown. So 6 squared is 36, 8 squared is 64, equals C squared. 36 plus 64 is 100. 100 equals C squared. To get rid of a square, you need to take the square root of both sides. So C equals the square root of 100. C equals 10. And so the length of the hypotenuse, C equals 10 centimeters. Okay, so this is a really easy, you're plugging and chugging. That's what the Pythagorean theorem oftentimes is, plug and chug type problems. You get, you have two things, you're solving for the third unknown. So we're going to have you go ahead and do a practice on your own. So this is 1A. So if I give you legs 3 feet and 4 feet, find the hypo. Go ahead, you can draw a triangle if you need to visualize, but you need to be showing your work in order to find the hypotenuse. Hit pause on the video and hit play when you're ready to solve. Alright, so in order to do this problem, you should have known that, well, if it's legs, I have 3, 4, I'm looking for this third side, so I'm looking for C. So I can plug into my Pythagorean theorem. A squared plus B squared equals C squared. 3 squared plus 4 squared equals C squared. So 9 plus 16 equals C squared. 25 equals C squared. Take the square root of both sides. So square root of 25 equals C. So 5 equals C. Remember, it's feet. So 5 feet equals the hypo, or side C. Alright, we're going to move on now. We're going to work with finding approximate lengths. To find approximate lengths, remember from section 1 of chapter 11, we talked about irrational numbers and how with the square root, if it's not a perfect square, you can estimate. And estimating, we'd be saying which perfect square is the number closest to, and we're guesstimating then. So for example, if I have a triangle here, we have a right triangle with side X, side 6 inches, then a hypotenuse of 9 inches. Well, this time, this is example 2. This time, I know I have A squared plus B squared equals C squared. I know I can use this formula because I have a right triangle. If I have a right triangle, I can always use this in order to find unknown side lengths. Well, so this time my side length here, it's not the hypotenuse, because my hypo I know. So I know I have 9 as my C. I know I have either A or B, so I'll plug it in for A here. So I need to find my other leg. I need to find B squared. So I can go ahead and simplify this. So 36 plus B squared equals 81. I'm going to subtract 36 from both sides, isolate B. B squared equals 45. Now I need to take the square root of both sides. B equals the square root of 45. Now, there isn't a perfect square for 45. 5 times 5 does not equal 45, 6 times 6 does not equal 45, 7 times 7 does not equal 45. So you're going to need to use estimation. Okay, so remember, you have square root of 36 is less than the square root of 45 is less than the square root of 49. The question is, 36 and 49, those are your closest your closest perfect squares. So which one is this closer to? Well, 36 and 45, the difference is 9. Between 45 and 49, the difference is 4. So you're going to say B is approximately, remember to use your approximate symbol, equal to 7. Okay? Because you're estimating, you're not saying it's equal to, but you're saying the closest perfect square is 49. So the closest square root is 7. Okay, I'm going to have you go ahead and do a practice with this. So if I give you a right triangle with a hypotenuse of 15 meters and a length of a leg 8 meters, find the unknown side to the nearest meter. Okay, go ahead, solve that. Hit play when you've figured it out in order to check your answer. Alright, you should have gotten, you should have been able to plug it into your Pythagorean theorem because it's a right triangle. Right, this is always a key point. Right triangle, Pythagorean theorem. So I have one side length, so I can plug it in for A. I'm still missing another side length, so I'll leave that as B squared. And then I have my third side length, I have 15 meters, so equals 15 squared. So 8 squared is 64 plus B squared equals 15 squared is 225. I'm going to subtract 64 from both sides. B squared equals 225 minus 64. 225 minus 64 is 161. 161. So you need to take the square of both sides. So B equals the square root of 161. Now, 161 is not a perfect square, so you need to figure out what's the closest square roots. Well, you know the square root, 144 is a perfect square, that's 12, is less than the square root of 161, is less than the square root of 169, is a perfect square, that's 13. Now the difference here is only 8, whereas the difference between 144 and 164 is much more than 8. So you're going to say that B is approximately 13. Okay. So now you can estimate, you're able to find either the hypotenuse or an unknown leg using the Pythagorean theorem, and you can also estimate based on perfect squares that you have memorized. We're now going to talk about the converse of the Pythagorean theorem. Now the converse means basically just the opposite. The converse of the Pythagorean theorem, it allows you to substitute the lengths of the sides of a triangle into the equation a squared plus b squared equals c squared in order to check. So we're going to use a squared plus b squared equals c squared to check, is this a right triangle? Okay, so we're going to be, instead of being given a right triangle and then we use it to find an unknown length, now we have all our side lengths. We want to say, is it a right triangle or is it not? So for example, if you have side lengths 12 meters, 15 meters, and 20 meters, you say, is this a right triangle? You can check it by saying, well, a squared plus b squared equals c squared. I can use the converse of the Pythagorean theorem. It's going to say 12 squared plus 15 squared equals 20 squared. Now I know to plug in 20 for c because that's the longest side. C is always equals the longest side. C, or your hypotenuse, is always the longest side length. A and B, it doesn't matter which one, because when you're adding, it doesn't matter which number comes first. But c squared is always going to be the longest side. Okay, so 12 squared is 144, plus 15 squared is 225, and 20 squared is 400. 369 equals 400. That is not true. 369 does not equal 400, so it's not a right triangle. Okay, this all here is your work to prove that it's not a right triangle. If it was a right triangle, then it should have ended up saying that 400 equals 400, and you would have said, yes, it's a right triangle, thumbs up. But if it's not true, if it does not equal, then you just put a slash through your equal sign, and then your answer is not a right triangle. All right, I'm going to have you do a practice with that. If you have 7 inches, 8 inches, and the square root of 113 inches, do those 3 sides make a right triangle? Go ahead and plug it in. Use the converse of the Pythagorean theorem. Determine if it's equal or not. Hit play when you've solved it. Alright, you should have plugged it into Pythagorean theorem. And you should have said 7 squared plus 8 squared equals the square root of 113 squared. So 7 squared is 49 plus 64 equals, well, the square root squared just becomes 113. 64 plus 49 is indeed 113. So 113 equals 113. It's true, so it's a right triangle. All right. That's it for today's lesson. It's just you plug and chug. You're either finding the length of an unknown leg, or you're finding the length of the hypotenuse, or you're using the converse of the Pythagorean theorem where you have 3 sides of a triangle. You're saying, does the Pythagorean theorem work or does it not work? If it works, it's a right triangle. If it doesn't work, it's not a right triangle. So your in-class work for today is to do on page 573 in your textbook, numbers 2 through 17. This corresponds exactly with what we've just been practicing. It's just a lot of repetition so you can really get that theorem memorized. And then your homework is going to be your practice book 11-2 in your workbook. So go ahead and get started on your in-class assignment. Make sure you're showing your work. Show all your work, including writing out the formulas. I know it gets tedious, but doing it every time is what helps you memorize it. You're going to be using it not for just for this class, but you're going to be using it next year as well. So it's important that that's one of those tools that's just part of your toolkit, and you always have it handy, ready to use. Go ahead and get started now.